Good evening. Am I audible? Okay, we'll begin the class in like 1 or 2 minutes. I guess we'll begin the class now. So, last week there was a question about what the. I'm sorry, give me a second. I'm so sorry, give me a second. Last week there was a question about why the FET had high input impedance and the bipolar junction transistor had a low input impedance. I have clarified this, and essentially input impedance is the for a good switch, it is necessary to have a high input impedance because give me a sec because we do not want it to accidentally switch on. The, input impedance is the amount of current you have to in short, a high input impedance is better for switches because you prevent accidental switching on. Secondly, a low input impedance means that you require you require more current to make this circuit work out. So that, I think, is the main question we had last week, which I was not able to answer. For this week, we'll look at sensors. The most of the entire week, this for the lectures 6 to 10, we looked at sensors and different kinds of sensors. The first entire class was basically a lot of definitions, which are necessary for choosing an ideal sensor for a given situation. Any mechatronic system requires sensors for before the actuation, and therefore knowing the different kinds of sensors is absolutely vital. Lectures 7 and 8 talked a lot about the different types of sensors. If there are any questions regarding specific sensors, please do ask. I can clarify them. Lectures 9, we looked mainly at the force and flow, and we also looked at lights and temperatures towards the end. Lecture 10 was perhaps one more interesting lesson which we studied about accelerations and a very interesting kind of sensors called microelectromechanical sensors. Are there any specific questions regarding lecture 6? Because I feel like there are you all admit. Okay, so we'll go to the specific concepts in lecture 6. In lecture 6, these are essentially all the topics which sir had covered, and I highly recommend that all of you have understand each of these terminologies specifically. It's necessary that you know what most of these terms mean, because when you're selecting a sensor for a specific application, you always look at these parameters. Let us, for example, take the case of a thermometer we use at home to check whether we have fever. when you're looking at a thermometer we use for at home purposes generally will start at like some 35 degrees Celsius, and it can measure to up to 43 degrees Celsius. This will form the range of the sensor. The span of the sensor will be the difference, and therefore the span is 8 degrees Celsius. We don't really know when I use the sensor at home. I really do not know what error is there in the actual measurements. But it is very but we can say that there isn't a hysteresis error in the mercury sensors. For example, in the mercury sensors work on the principle that there is expansion of a liquid given a temperature. This is not very hysteresis is not necessarily a issue here, and neither is nonlinearity. The accuracy of the sensor, accuracy of our thermometer is. Oh, I must also add, in case I'm speaking too fast, please do raise your hand or give some indication, and then I will slow down if necessary. Okay, I will slow down. Okay. The accuracy of a thermometer, if you look at the like in case of the temperature thermometers we use at home, the accuracy is actually not more than 0.1 degrees Celsius, because and likewise the sensitivity. The definitions of repeatability and stability should be fairly intuitive. Repeatability is essentially how often you can get the same value from the same input. Thermometers are supposed to be quite repetitive. Stability is given a steady input, do you get a steady output? And later you can see one of the sensors, specifically the piezoelectric sensors. Yeah, the piezoelectric sensors are actually not quite stable. They tend to lose their output fairly quickly. However, the thermometers are quite stable. There's no issue of that. Deadband is the amount of input for which there is no visible output in the thing. For example, in our case, the thermometer will not give us an output until 35 degrees Celsius. Dead time is the time taken for the dead time is the short period of time for which the output does not. The output takes, given an input, it takes the output to catch up. For example, in case of if you try to draw a graph, if you try to draw a graph of the input, say we give an input at this time, the temperature need not rise up immediately, and for a short period of time, say it's reading 26. For a short period of time, the temperature might not increase, and that is what we'll call the dead time. The resolution is the smallest amount of input that can be measured. This makes more sense for in the case of a mercury thermometer, the resolution is essentially the least count of the thermometer itself. However, for say analog for digital thermometers, okay, not digital thermometers, consider an optical encoder. In an optical encoder, we can say that if you have a if you have a 4-bit encoder, that means if you have a 4-bit encoder, that is okay. If you have a 4-bit encoder, the number of angles in a optical thing is 360 degrees, and if you have a 4-bit encoder, a 4-bit encoder means we can measure 2 to the power 4 values. This is because you only have 4 digits, 1, 2, 3, 4, and each of these digits can take 2 values. Therefore, you get 2 to the power 4 possible values from a 4-bit encoder. That means the resolution of this encoder, that is, for a change in the output has to change from 0, 1, 1, 0 to 0, 1, 1, 1. For a 1 bit of change, we'll require to change the angle by 2 to the power 4, because I'll make it to the power 3 because it's easier to draw. So say you're here, you'll require to move the wheel an entire 45 degrees before the output changes. Therefore, the resolution of a 3-bit encoder will be 360 by 2 to the power 3. Response time, time constants, rise time, and settling time, all of these can be better understood from a graph. Say you have a give me a second. Yeah. So clearly let's call this output 10 volt. The specific details of response time, the number given in the slides is 95%. So if that's 10 volt, we'll say this is around. So the time taken for the output to reach here, this will be the response time. Likewise, the time constant, the time constant is something more mathematical in nature. We get the value 63.2% of the output here, and this is from concepts of half time and and stuff. So in this case, the time constant will be less than the response time. The rise time and settling time, the settling time is more interesting, because say I want to find the settling time until it's 2% of the output. That would be 2%. between 9.8 and 10.2. While it does cross 9.8 here, while it does cross 9.8 here, this will not be the settling time. The settling time will only be around here, because only after this time is all the output within 2% of the output. So there is a small, after this time we can say that all the output is always within 2% of the of the actual value, and this is what we'll call the settling time. The rise time the rise time is a similar thing. I should have written this down. Okay. So that concludes most of the terminologies of a thing, of a sensor. If there are any questions regarding any specific kind of sensor, or you want to work out another kind of thing other than a thermometer, and s- uh, I'm free for questions. I hope you can speak. If not, muted people, right?
Yeah,
I
sorry, yeah, they can, yeah, can speak.
Okay.
Yeah,
Okay.
thank you.
Good to know. Okay. Lessons 7 and 8, we talked was main essentially about position sensors, because position sensors are a vital part of many mechatronic systems. We first started the potentiometer, which basically works on the principle of different resistance being proportional to length. I do not think there's more to add to that. Yes? Am I speaking too fast?
Yeah,
Oh,
here I have that this rise time and this response time. See,
yes.
response time is almost the output is reaching to the 95 percentage.
Yeah.
Is it correct?
Yes.
So here rise time we are saying about that it's going to 10 percentage to 90%, 90 percentage or 95 percentage for the rise time.
Yes.
So how to, there is a confusion whether the response and rise time it is part of that rise time is part of the response time, or how to be.
I will clarify this next class. If it was
Okay.
for, while explaining the concept, I suddenly realized these two concepts were the same, and I believe I've made a mistake. I have to read Bolton to clarify. I'm sorry.
Yeah, yeah,
Yeah,
okay, okay,
good question.
thank you.
Thanks. Yeah. So we'll continuing on. Strain gauge i- measure can gives us a change in resistance. The main kind of strain gauge gives us a change in resistance given a change in length, and uses the principles of strains to for uses the principle of strain to change the resistance. I have personally used strain gauge a few times, and it's quite accurate, and I guess it's a good displacement sensor. Capacitive elements such as give me a second. Yeah, there are the essence of capacitive sensors are capacitive position sensors are, we have a capacitor with, and we know that the ca- the capacitance of this capacitor depends on the dielectric medium inside, and therefore on changing the dielectric medium we can change the capacitance, and this essentially gives us a measurable input. Note that the important thing about all of these sensors is we need to be able to convert the specific signals from mostly mechanical states to electrical signals, because because that's a premise, because all the what's that thing called, all the controllers and actuators use electrical signals. Therefore, it's necessary that we convert all the position, force, and flow, from which are essentially mechanical concepts, and find its convert all these measurements into electrical signals. That's why potentiometer directly converts position to resistance. Resistance is quite is a electrical concept. Likewise, strain gauge also gives us a output and resistance. Capacitive elements like capacitors with capacitive elements like capacitors whose dielectric can be moved are also give us an electric output, since we can measure the change in capacitance. LVDT, the linearly variable differential transformer, which is quite the mouthful, is incredibly is similarly incredibly nice position sensor. And if it was not for the expense of making it, it would have been used in many more places. Like potentiometers and strain gauges are unfortunately affected by temperature also, but that's not the case with LVDT, and this allows LVDT to be used in more more cases than the more cases, like for example inside engines, for example. One interesting thing is the first few position sensors are all analog in essence. That is, we are not discretizing the output. Encoders, on the other hand, give us a specific outputs. For example, what's that thing called? Which encoder was it? The basic kind of encoder if you shine light through these holes and have a light sensor on the other end, and you can just keep counting the amount of times light has been shown on the sensor, then you'll be able to get at which point the wheel is right now, if the wheel is rotating here and wheel is rotating and so on. The slides explain that in general we actually use 3 holes instead of 1, and that makes sense, because we need to, given this is easier to show in the diagram. Because of a slight change in the displacement, if light shines, depending on which ring gives us the output first, it is possible for us to say whether the wheel is spinning clockwise or anti-clockwise, and that will help us give us the angular orientation. And the final ring is to give a reference point to say that this is the let's say this is the origin, or something of that sort. Absolute encoders are much nicer in my opinion. So in the case of absolute encoders, we have marking at a lot of discrete angles, and each of these markings will be unique. this will depend on the number of bits we are using to encode the values. So say we have 8 bits. If you have 8 bits, that gives us 2 to the power 8 combinations. And that gives us, that's almost as good as 1 degree per value, 1 degree per encoding. This is like 256 and we have 360 degrees. And that brings us to one, and like we can name these normally. It's like say this is 000. Okay, instead of 8 bits we'll have 3 bits again. If you have 3 bits, we can name these 0 0. We can name this 0 1 2 3 4 5 6 7. But the issue is, all of these will be represented in binary. If you are looking at these in binary, we get 0 0 0 here, 0 0 1 here, 0 1 0 here, 0 1 1 here, 1 0 0, 1 0. Is there any question about how I'm writing these numbers? Okay, I'll assume there's no question and you're familiar with binary digits.
Yeah, actually, these I have the doubt about that the binary code and the gray code.
Yes,
There
I was
was
coming to I'm coming to that. Essentially,
yeah.
I should block notifications. Yeah. So this will be the thing in binary digits. Now, one small issue with binary digits is that as you change from one bit to the one value to the other, here there's no issue. We are going from 0 to 1 and only one bit is changing. That's perfectly fine. But say you're going from 0 to here. Now 3 bits are changing. That is, this 0 is becoming a 1, this 0 is becoming a 1, and this 0 is also becoming a 1. This might seem like a small issue. However, say the wheel is spinning while we are taking this measurement. If the wheel is spinning while taking the measurement, we might read the first 0 from here and then read 1 1 from here. So instead of reading 0 0 0 or 1 1 1, we'll be reading 0 1 1, which is all the way on the other side of the wheel. This is not good because we are essentially getting a massive mistake in reading the wheel. We are literally completely out of phase with the reading. Therefore, we kind of want to choose digits in a way that there is only one bit of change in both directions. Does the motivation behind this make sense? Essentially, we do not want to have multiple digits changing. No, I granted there are few cases where only a single digit is changing. But in all the other cases, there are 2 or more digits changing, and that's awful. Therefore, we'll talk about gray code. Now, gray code is the idea behind gray code is simple. No matter, even though you're not using the traditional binary digits, saying let's say 0 1 0, this need not be. This is equal to 2 in base 2. However, in gray code, this is not 2. Gray code is a different set of mapping, so that 0 1 0 will be mapped to something slightly different, and we'll see how that happens. I will write down the gray code for 3 bits. For 3 bits, we have 0, 1, 2, 3, 4, 5, 6, 7. 0 is mapped to 0 0 0. 1 is also mapped to 0 0 1. 2 is mapped to 0 1 1. 3 to 0 1 0. So surprisingly, 0 1 0 in gray code is actually 3. I will tell you how to. I'll teach you how to generate this in a short while. 4 will be 110. Yeah. So these will be the 3-bit gray codes. So if you look at the same thing in the wheel again, we'll see that, yeah. You can see that no matter where you're going, there's only one bit changing. Yeah, if I'm honest, I'm also verifying it, that I'm making sure that I'm correct while going through this, because it's it would be a little awkward if I make a mistake here. But yeah, here you can see that no matter where you're going, there's only one bit changing. This is fine, right? Yeah. So to be fair, there is not a very obvious way to tell you that 5 in in gray code is 111, because unfortunately gray codes change based on the number of bits you have. So if you have 4 bits, you can go up to 16, 15, and the values you get will be 0 0 0 0. I'll write it down. Just to clarify, have not memorized this. There's a small pattern, and I kind of wanted you to figure out what the pattern is. One hint I can give you. Am I too fast? I'm sorry. I will speak slowly again.
Sir,
Yeah.
yeah, actually in 3 bits, you have mentioned 0 to 7 number.
Yeah.
While in 4 bits, I think you have mentioned.
Yeah.
Uh,
In 4 bits, you'll have 0 to 15.
so how these are calculated 0 to 7?
Because 3 bits means you can have 2 to the power 3 numbers.
Yeah.
So if I list them out, it will be all numbers until 7. Like between 0
2
and
to the
7, there are
power
8 numbers.
2 to the power 3 is equal to 12, na?
2 to the power 3 is 8.
Oh yeah, 8.
Yeah.
Okay, yeah,
Yeah.
understood. Yeah.
Okay. So and 2 to the power 4 will have 16, and therefore you can have numbers from 0 to 15.
Yeah, yeah.
Yeah.
Thank you, sir.
Okay, so what I was going to say is, one hint I can give you about the gray code is that if you flip the gray code, it is still a valid gray code. So imagine I take this and flip it. So instead of going from 0 to all the way till this number, I go from 100 and go in the reverse order. Now, the interesting thing is, this is still a valid gray code. If I define a gray code as a set of numbers where only one bit is changing, the order does not matter. So if I read a if I say this is 0 instead, and this is 1, everything still makes sense. This is still a valid set of gray code. There's only one bit changing at every change. In all of these, only one bit is changing. Therefore, you can generate a very recursive way of getting the next value of gray code. That is, say you know the gray code for 3 bits. I shouldn't have erased this. Say you now I take the 3 bits and I generate the flipped version, which is also a gray code essentially. And then for the 4-bit gray code, I just paste it in the bottom. Take the 3-bit stuff, flip it, paste it in the bottom, and I add a 1 in front of everything in the front. So to give okay, I'll start again. So it's definitely not clear the first time you see it, because it took everyone a good solid chunk to understand how wonderful this is. So say we have a yes. Okay. So say we have a 3-bit gray coding. By the nature of the gray code, if I flip the gray code, I will still get another set of valid gray code. That is, if I'm saying gray code is a set of digits, is a set of numbers whose digits only change by 1, then this is a gray code, and this is also a gray code. This is a gray code. This is a gray code, and this is also a valid gray code, because only one bit is changing at every instant. In the first case, the first bit is changing. Second case, the second bit is changing. Third case, the first bit is again changing. Fourth case, the third bit is changing, and so on. So to generate the 4-bit gray code, you take the 3-bit gray code, you paste in the you take the 3-bit gray code. Oh, that's not the 3-bit gray code. You take the 3-bit gray code and then put zeros in the front. And then you take the 3-bit gray code, you flip it, and then paste that at the bottom. And in front of the flipped one, you add ones. Now, that will guarantee that between every bit, there's only maximum one bit of change. What is a little interesting is, knowing the gray code for it's to make if you know the gray code for a number, you need not really know the gray code for the number in higher bases. I mean, you will put zero. You just have to put zeros in the front, but there's no way to say that 11111111 represents phi otherwise. You have to generate the gray code once to know if that 111 gives us phi, and then you can proceed. So does that make sense on how to generate gray code? And does the motivation behind using gray code make sense? Yeah?
Yeah, as I'm understand, as per our your this new this technique, this method, like I what I am understanding, 2 to the power of n minus 1 should be the first, last digit will be a 0. Correct? Is it correct?
2 to the power n minus 1, the last digit
1.
is 0.
That means up to that, for example, you told, if a 4-bit means 2 to the power of n minus 1 is 8. Up to 8 digit, the starting will be a 0. When go for the from 9 to 16, that will be a leader line will be a 1.
Yeah.
Same like that, if your 3-bit means 2 to the power of n minus 2, up to 4 digit will be a first leader will be a 0.
Yeah.
And after that it will be a 1.
Yeah.
Okay. Okay.
That's absolutely correct.
Yeah. Thank you.
So that kind of explains what gray code is. A very fun assignment is to generate your own gray code and plot it on MATLAB, but that's a little out of the scope for this. Yeah, that concludes gray code. I hope, are there any more questions about gray code? I can explain. I have accidentally gone a little faster, so we are a little ahead of schedule.
Sir, can you please tell once again 2 to the power n minus 1 concept?
Okay, so the idea is a binary digit means you can either have binary means 2. So binary digit means you can only have two things. You can either have a 0 or a 1. Those are only two numbers you're allowed to use. If you're only allowed to use these two numbers, then but you can use as many as these numbers as you want. So okay, sorry. In maths, you can use as many numbers as you want. So for example, if I say 1 0 1 1 0 1 0 1, this definitely corresponds to some to some number like 1 4 16 32 128. If I add this 20, 160, 180. So this number in base 2 will be 181, I think. So how did I get this? Essentially, in binary digits, we go like 0 is obviously 0, 1 obviously goes to 1, but 2, there's no number 2 in binary digits. So you do the most logical thing. Like, we don't have a single digit for the number 10. We have two digits for the number 10. So similarly, 2 in binary digits will be 1 0. 3 will become 1 0 plus 1, which is naturally 1 1. 4, if you, by the same logic, we can't have 2 here, we can't have 3 here, we can't have any bigger number digits here. So what we'll do is we'll go to 1 0 0. And therefore, with a little bit of practice, it'll kind of make sense why this number is probably 181. Now, but we are engineers. We only have a fixed number of digits we can use. I mean, we can't have infinity anywhere, anyways. So we constrain for the output of sensors, the output of different even in computers, we constrain the number of digits we can use. So if you are using, let's say we are using 5 bits. If you are using 5 bits, that means you only have 5 places to put zeros and ones. The smallest number you can put is 0, 0, 0, 0, 0. And the largest number you can put is 1, 1, 1, 1, 1. This corresponds to 0, and this corresponds to 63. I think. Oh, no, that's too big. I think it's 31. Okay. So, if I slowly change every number from between this and this, between zeros 0, 0, 0, 0 and 1, 1, 1, 1, 1, I can generate every number between 0 and 31. So if I say 1 zeros 1 1 0, that this will be one such number in this range, and I think this will be like 24 or something like that. So another way you can do know the number of digits you can one number of numbers you can represent is by using combinations. Each digit gives us chance for 2 numbers. So we'll get 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, which is 2 to the power 5. So we can represent 2 to the power 5 numbers with 5 digits. This is all well and good, but the issue happened with representing these numbers on the optical encoder. If I represented it normally, like if I'll write the binary numbers from 0 to 7. If I represent these in the disk, you can clearly see that there are cases in which the number of digits is changing by 2. I mean, here, sorry, this will be 0, 1, 0. Here we have the third digit and the third digit changing, and the second digit and the second digit changing. This is not good, because as I explained earlier, say the wheel, say while you're reading this, the wheel moves. So you will read one digit from one and the other digit from the other, and that in this case it could be read as 0, 1, 1. Okay, 0, 1, 1 is not a big issue. 0, 1 is just here, so that's fine. But you could read this as 0, 0, 0, which is also not that bad. But the earlier example was much more dramatic. Like when 0, 0, 0 changed to 1, 1, 1, it becomes 1, 0, 0, which is all the other end. We should not, in a mechatronic system, the sensors have to be accurate. We cannot have the sensor giving completely incorrect values like this. And therefore, instead of using the normal binary digits, we use gray code. The good thing about gray code is only one digit changes every time. So, and I explained a little while earlier how to generate gray code, any n-bit gray code. So if I have the n-1 bit gray code, I can generate the n-bit gray code using this pattern I had told you. With the n-1, I just copy the n-1 and paste it here. I copy the n-1 and I paste it here. And then I put zeros. I put zeros in the front. Then I flip the n-1 and I get a completely different gray code which looks completely different. And then I paste that here. In front of this, I will be putting ones. This generation gives us a very nice. This generation is a kind of beautiful in my opinion, and we can get the n-bit gray code given an n-1 bit gray code. So with this, you can essentially generate a 10-bit gray code, but only going to take you a lot of repeated steps, and that's why I would say it's better to code this than to manually write it down. Now, because of the way this is generated, clearly the first digit will be 0 for half of the terms, and the first digit will be 1 for the second half. So in a 4-bit case, we have 2 to the power 4 digits. That means 2 to the power 4 divided by 2 will have 0 in the first bit. Yeah, and that gives us 2 to the power 4 minus 1. In general, 2 to the power n minus 1 bits, 2 to the power n minus 1 numbers will have 0 in the leading term. I guess that's the question you had, why 2 to the power n minus 1 comes, or do you mean why 2 to the power n minus 1 is the number of digits number of numbers? The reason we have the last number is 7 and not 8 is because you're counting 0 also. Like, if you're counting 0 as a number, then we cannot, then we'll have this already adds up to 8, right? So that should tell you a little bit about gray code and binary digits. Is gray code simply a combination of binary digits based on the length called bit? Gray code is a specific order of binary digits for which, when you add, if you look at the next number, the bits only change by 1. A bit is just short for binary digit. BIT, binary digit. So yeah, you can say that 010 is the binary digit representation of 3, but it's specifically the gray code binary representation. I personally wouldn't say it's a binary representation of 3, because when you say binary, we generally have the math, we generally look at it from a math point of view, and therefore the binary representation of 3 would be this. Is gray code simply a combination of binary digits based on the length? So a gray code is a set of binary digits for which is a clear mapping and how the numbers, and specifically on this fact that the digits should only change by 1. Yes, Harichandra?
Yeah. See, it is very clear. Binary digits, it was increment of one number of the binary. The earlier we can consider as a 1, 2, 3 sequentially it was increasing.
Yeah.
It is easy to understand that. But the gray code, how system can be understand that? Suppose one digit here, one digit only changing, but it should not be sequential. One after that, in gray code, it is like that. One digit only changing.
Yes, one digit is changing.
But it mean to say it may be descending order, it may be ascending order of the binary. Because like this.
No. So in binary digit, this 011 is not 3. I mean, sorry, in gray code, 011 is not considered as 3. 011
Yes,
is considered as 2. So,
consider as a 2.
yeah.
Okay.
So it's not
So,
like it's not like we are going looking at this and saying this is 0, 1, 3, 2, 6. That's not the way we are looking at it. We are defining 2 as
yes.
011, 3 as
Yeah,
010.
that my question is how the system is okay. It's okay. Now system is like, for example, the 2011, that internally sensor how it can be understand that.
Oh, that depends on the. So the easiest way is if you have a disk and you put holes.
Yeah.
So okay, we have put holes and we close some of these holes, and we close the holes based on the thing. So for example, we close this hole, we close these two holes, we close this hole, we close these two, we close these three, we close this and this, and we close this. So now if I now I have a light emitter which I keep here, which I just keep behind this. So the light emitter is here. The light emitter will be here. Just to clarify, the entire disk is opaque, so the light can only come out from these holes. Okay. Now, if the wheel rotates, how do I draw this again? Yeah, I can't rotate it. Okay. So when the real wheel rotates, eventually this this fill open fill will come here. When fill open fill comes here, only one of the lights will go through because the other things are blocked. So if you have a sensor on the other end, that sensor will read no light, one light. Sorry, yeah, no light, one light, no light, which in this case will represent 7. I got the order wrong, so I should have filled the other way around. In the as in this should have I should okay. Give me a second. I'll fix the entire thing. So I am I'm filling these holes, and I'm filling them based on what the representation is supposed to be. So for every time I see a 0, I'll fill the hole. For 001, I'll fill the first two. For 011, I'll just fill the first one, and so on. Yeah.
This third one, it is the 3 o'clock position. The first will be also filled 10 because the 010, no.
You're right. Hmm?
Yeah.
For if every time there's a 0, I'll fill it. Here there's only one 0, so I'll only fill the first one. Here there are two zeros, so I fill the first two. So this is right. Like, I should have done this both in the same. Yeah. Yeah. I should have done this earlier. Okay. So wherever there's a 0, I'll fill the hole. Wherever there's a 0, I'll fill the hole. So 001 means I fill, no fill, no fill. 011 means fill, no fill, no fill, and so on. So I think this is correct. Now I'll put a light emitter in the front, and I'll have 3 light emitters right behind the each of the holes. Okay. So the thing will look like, if you look at the side view, it will be like there's a light emitter here, and there is 3 light sensors here, and these light sensors will be positioned so that they'll only get light from each specific hole. So as the wheel spins, say I read 001, that is, this receives no light, this receives no light, and this receives light. And then I would call that 001. And we know 001 means it's the first one. Similarly, if these two are the only ones which receive light, then that we get a 011, and that is a 2. Does that make sense? This is how we'll use gray code in real life. Naturally, if you're using gray code in real life, we'll have many more bits. And secondly, the holes won't exactly be like this. The holes will be like solid 1/8 of the, will be quite big, so that we'll always have light no matter where we are, instead of just small holes here. Like, it's difficult to draw, therefore I didn't draw it out specifically. If I remember correctly, the slides had a decent picture of. Yeah, see, there are holes the entire way. Holes or no holes in the entire way. Is it clear? I mean, is the video clear? Yeah.
Yeah, clear,
Okay,
it's clear.
Oh, so this is not the gray code. Oh, is there no pic of the gray code? Okay,
Yeah,
so
that's
yeah.
what gray code, there is no explanation given. That's what I asked the question.
Okay.
They've given absolute encoder demo.
Okay,
only.
so essentially we never actually use absolute encoders like this. We only use absolute encoders with gray code in the with the gray code in the shaded region, not shaded region. For the reasons I've told you in a short while back. So I hope that makes sense. I felt like gray code was a very fun part of especially the coding aspect. So if any of you want to code this out, please feel free to try out. It's not. If you know a little bit of MATLAB, it's very nice. It's a little more difficult than most other languages, unfortunately. Okay, so that concludes gray code. Then we have the other proximity sensors like capacitive proximity, pneumatic proximity. Yes?
Here, when we are using this, if any of one, like gray code sensor or absolute sensor,
Yeah.
when we are integrating with our sensor with our mechatronics system,
Yes.
that this how it mechatronic system can be identify this sensor is giving the input like the position, how to that manufacturer give the configuration, or we need to build that program like that
So
sense of that
in
position.
most cases, unless you're coding in a really low level system, the output will be the angle itself and not the gray code value.
Yeah, that's what here that little bit different. The absolute encoder angle is different and gray code angle is different. Suppose it was sensing the 22.5 degree in that position in absolute, that may be different in that gray code sensor.
No,
Or
no,
both are same.
in general, for example, if you're buying motors, if you're buying servo motors, then you won't need to care about the gray code implementation of the encoder, because the servo motor will itself come with a controller inside, and that controller will know about what the gray code values are. If you're building a servo motor on your own, then you will need to know about gray code and how to make the controller. But if you're buying servo motors in general, you don't need to know about the specifics about gray code. However, if we had bought a switcher motor, and we had to get the value of the positions from what we did for relative encoding. That is, we had to identify the position from this setup. So in the end, I guess it depends on the manufacturer. As in, we had 3 outputs from the encoder, and we had to put them in a microcontroller and program it in such a way that we know what position it is.
Okay, clarify.
Yeah.
Yeah, thank you.
You're welcome. Now we will go to I'm not sure there's anything to add about the capacitive and pneumatic proximity sensors. Switches are very important concepts, and I mean very simple concepts also. And I think the slides captured most of the nuances. Another kind of position sensor is are like lidar sensors and ultrasonic sensors, which I'm a little surprised Sir had not mentioned. For the ultrasonic sensor is essentially we have two speakers which give a specific what's that thing called? A specific frequency of sound, and we know that sound gets reflected when it hits a hard surface. So if you have a set of speakers close to a hard surface, sound the speakers, the wave from the sound wave from the speakers will hit the surface and bounce back, and this bouncing back can be captured by a sound sensor on the sensor. Now, since we know when we send the sound, and we know when the sound sensor received the sound back, we have a time. That is, we know at t naught sound make sound, at t1 I hear sound. That means this will be the time taken for the sound wave to go to the obstacle, hit it and come back. because we know the speed of sound, we can say that the distance that the sound wave traveled is c multiplied by so and so. And if we divide this by 2, we'll get the distance between the sound sensor and the wall. Know that this happens really quickly. So you need to have a decent sound sensor and a good sound generator for this to work. However, this is a solved problem essentially, in the sense we already have excellent ultrasonic sensors in the market right now, and it's not very expensive either. Yeah, and so certain things that which are important about what's that thing called ultrasonic sensors are, if the wall is too close, then the sound sensor, the T1 and T0 will be so close to each other that the resolution will be, this is where the bit things comes again, because the resolution is too less now, and the ultrasonic sensor is not able to figure out where the body will be. Similarly, if the wall is just too far away, the ultrasonic sensor won't get a rebound back, and therefore the ultrasonic sensor will not give the right value. There are actually a couple of issues with ultrasonic sensors. For example, you might accidentally there might be a closer hard obstacle, and the ultrasonic sensor might measure that instead. But if you properly configure your ultrasonic sensors and things like that, ultrasonic sensor is sometimes a very convenient and inexpensive solution for position sensors. So we talked about most position. Then there's the Hall effect sensor. Do I need to explain? The Hall effect sensor is also a very interesting sensor. The Hall effect sensor essentially gives us a potential output given a presence of a magnetic field. The Hall effect was identified a really long time back. Essentially, if you have a wire carrying current, and there's current flowing, and if you place this in the presence of a magnetic field, because we know magnetic fields affect the flow of electrons, we'll get electrons to slightly drift, and that therefore one region of the conductor will have more electrons than the other. And so because one region of the thing has more electrons than the other, this essentially forms a form of a capacitor, and because it forms a capacitor, we can find the potential difference across these 2 points. Therefore, we can measure the presence of a magnetic field based on this potential output we get. Remember, in the end, what sensors are supposed to do is convert any mechanical effects into an electrical effect, and this electrical effect might also be in analog or digital. So, likewise, there's the tacho generator, and I don't think there's anything extra to add in the tacho generator. Are there any questions about most position sensors? If not, let's continue to force, flow, temperature, and light sensors. Okay, for force sensors, a spring is naturally a very intuitive thing to use for a force sensor, because essentially we are now, instead of measuring force, using a spring we can measure length instead, and we already found several ways to measure length. Instead of measuring force also, we can measure pressure, and there are several ways you can measure pressure. For example, using the barometers and things like that. Then there's the piezoelectric sensors, in which the application of pressure generates charges, and this we can measure with these charges. We can quickly identify how much pressure is being applied. Then there are also tactile sensors. Uh, th- gi- Give me a second. I'm just clarifying if I've missed any concept. I don't think I have. Okay, so in the one person had asked a question in the forums asking why they use the word fluid instead of air, but I believe that fluids includes the concept of air also. Fluids is anything that flows. Air flows as well. Therefore, it's not necessary to have specified it's air and not fluid. If that person is here, please do ask. I'll try my best to answer.
So this is reference to the one. This is reference to one of the questions which is there in assignment, I think.
Yeah, and I do not think I'm allowed to answer that outright because this is how we have
No,
marked.
actually, just I put that question in like our discussion actually. Just for the forum, if anyone knows about that, the question was actually it is difficult to control the speed of the pneumatic cylinder due to dash. Piston velocity is low, airflow rate is constant, compressibility of a fluid, all of the above. But here we are talking about the pneumatic system and the cylinder, so we have to consider the air. So in the slide, there is a clear answer due to the compressibility of the air. It is difficult to control the speed, but in the given answer, out of given answer, there is no point. The answer is piston velocity is low, airflow rate is constant, and
But
compressibility is
air
of low.
is a fluid.
So,
Air is a fluid.
okay.
Like so, uh, because air is a fluid, why will it? It's like saying a square is a rectangle. So you can just instead of saying things about a square, you can talk about the rectangle instead, right? Air is a fluid, so it doesn't matter that we are using the word fluid instead.
Uh, you mean
Fluid is essentially anything that flows. Air is a fluid. So if the issue is what's that thing called? I don't have. Give me a second. Let me see the. Yeah, it's if you're saying compressibility of the it should have been written compressibility of air instead of compressibility of the fluid. But air is the fluid, so there's no harm in saying compressibility of the fluid instead. Fluid is
is
a
it okay?
fluid is a all encompassing word for anything that flows, right? So it's I think it's fine for if they have
So,
used.
yeah, so you mean you can choose the answer like due to the compressibility of the fluid, because we are not seeing the compressibility of the air in the answer given.
Yeah,
So I think it's okay to consider the speed of the control is difficult due to the
compressibility of the
compressibility of the fluid.
like
Okay.
yeah, but I'm just a little uh
Yeah, just
confused
I
because yeah,
whatever.
no, I think
Yeah.
this is a
Yeah.
issue of terminology, and therefore I'm justified in kind of revealing as is the answer. I am yeah. I'm not
Yeah.
allowed to. I've been explicitly asked not to reveal the answers, so I'm sorry. Yeah,
Okay.
yeah.
Yeah. No worries. Just it was kind of even I gone through the slides a couple of times, but I didn't get a clarification, so I dropped
Okay,
the mail to the
okay, understood. Yeah,
to the team to get it
yeah.
clarified. Yeah.
So,
Thank you. Thank you.
thank you. Okay. Purushottam, what do you mean by is media word? Is media word is okay? Hmm?
Yeah, I just want to add air word is used for as a fluid, na? So can we use instead of air is media? Means air is a media or
Air is
fluid is a media?
air. I mean, it depends on the it depends on the question, right? Like in some places, it's weird to call it media instead of air. For example, in this case, I wouldn't call it compressibility of the. Okay, I mean, I could. Compressibility medium does make sense, but I guess the it depends on the scenario. In some, if you're yeah, it depends on the scenario. I'm not able to think of a scenario right now where I'll use media instead, but you can kind of use media for the for when you're talking of flowing in air.
Yeah. Thank
Yeah.
you.
Okay, so continuing, yeah, we just finished talking about tactile sensors. I think we finished. Yeah, I. Then we go through flow sensors. There's the all different kinds of flow sensors. Are there any questions about these flow sensors? There are equations in the slides for flow sensors, but this is the Bernoulli equation and the continuity equation. And while we can solve questions about that, it's essentially just plugging and chugging the answer. Like just like finding the resistance in the previous slides, in the previous class. Do we have to solve question? Do you want me to solve a question on Bernoulli equation? I'll take that as a no. I'm not very enthusiastic about such kinds of numerical questions. Okay, so I mean naturally, if you do have a question about it, I'll generously solve right now. But yeah, so we saw there are different kinds of flow measurements. There's the orifice plate. There's the turbine flow meter, which has a very nice diagram. We can look at, because of the Bernoulli equation, we know pressure is related to height, and therefore we can also use liquid levels to measure the pressure. The float system is perhaps the simplest solution. Instead of measuring the actual height of the liquid, we can measure the height. Instead of measuring the pressure, we can actually measure the height of the liquid using a float system, and that's a nice solution. Then there are differential pressure sensors, and then to measure, then there are many ways you can measure temperature. Bimetallic strips is the most common thing. You might have seen bimetallic strips inside uh, fire alarms. In fire alarms, I can draw here. In fire alarms, there's a massive circuit, and one part of the circuit contains a bimetallic strip, which I'll represent like this, and it on the other end is a switch. So as it becomes hot, the bimetallic strip will bend and thus touch the switch. When it touches the switch, the circuit is closed, and therefore the fire alarm will start ringing. So bimetallic strips are useful in these applications. Then there are ways to measure temperature using resistors and stuff. Note that a bimetallic strip is essentially kind of like an uh, on-off, on-off, and on-off output. Either bimetallic strip is giving a value or not. We don't have, we can't measure specific temperatures using this setup. Though perhaps with a slightly modified setup, we can measure the curvature of the bimetallic strip, and that gives us the temperature also. But an easier solution is essentially to use resistance temperature detectors or thermistors or thermodiodes, which all have very nice, which are all very well studied. Even thermocouples Yeah, thermocouples are very nice also in the sense that they straight up generate an potential difference, and as in given a specific uh, for given a specific temperature difference, we'll get a potential output, which is what we need in from sensors. Additionally, there are phototransistors. Yes, am I going too fast? I'm sorry.
Yeah, here
Oh.
that last time the question was asked, the thermocouple is a high temperature like this. But if you see that some of the ranges, it is also going to measure with the minus 200 degree also.
Give me a second.
Yeah, in this our last questions, like you can you open that our question set two?
Yeah, I can. Yeah, I was just clarifying if the answers were given.
It's not the high temperature. Thermocouple used to measure the high temperature. Okay, but the such a case, some of the materials like chrome or aluminum, it's having the sensibility is minus 200 also. So that the
No,
case,
the
there is
thing
a
is,
differentiate how we
we.
can tell that.
Mm,
Yeah.
you are correct in that, but we are essentially. Give me a second.
Yeah.
Which one is this? I was wondering if there was something in the slides to denote this, but like if you look at, you are right. It is possible to make thermocouples in a manner that. So I'll show this diagram.
Yeah, because why this question was raised
Yeah, I get
to.
you'll get marks. I know, but like unfortunately, I do not have contact of the professor. I must
Yeah,
talk a long
this
way to speak to them. Okay, so essentially, if you look at here, normally the hot junction is the one which you're going to be using to measure the plate, and the reference junction is always cooler. Though it is possible to have the reference junction hotter than the to instead have a cold junction instead, but like essentially we normally use thermocouples for hot temperatures. I think that's the issue. Will talk to the I'll talk to the teacher in charge, and I will clarify this. I have to write this
so
down.
why the question is whether because some of the systems which we are using at that suppose like I'm working in the railway industry which we are using the thermoresistors on that this one the train will run on that minus temperature as well as plus temperature. So such a case, this thermocouple can be used as a sensitivity of that windscreen. It's a minus also.
Yeah, you're right. It's true. We do use thermocouples for what's that thing
Yeah.
called, for
So
cold
we
also,
cannot. That my question is like we cannot fix it. It is only thermocouple for high voltage.
for high temperature.
Sorry, high
Yeah.
temperature. So
No, no, sir. Here, I discussed with my colleagues as well. The thermocouples. that RTDs we are used to measure the temperature, higher temperature, not the low, or even to measure the nominal value of the temperatures. The RTDs, resistant thermocouples, are used to measure the high temperatures. Yes, even had this kind of confusion before I select the answer that to measure the high temperature. Yeah, they've given a, because when it goes to the lower temperature, the thermocouples will not be like a kind of a sensing or some justifications values they're given. Yeah, it is good to check with the sir. Yeah, I must
I
say.
will clarify with sir, because if I remember correctly, you have to specifically make a thermocouple to measure low temperature. I mean, to measure really low temperatures. But it should be possible from the theory that to make it. But in general, I have seen thermocouples mainly used for high temperatures. So I guess that's the reason why Sir has mentioned it like that.
Sir, and then before that one, where they are checking the given answers and other stuffs in my tab, actually in my the home page, in my login page,
Yes.
just I can see how much the marks I gained, and then what is the status. But I can't see what are all the correct answer, right answer in my home page. However, you are shown the green one, the correct one, and wrong one in my login ID. Is there any particular tab where I can go and check what
Wait.
is the
Do
assignment?
you see this? Will do you see the same tab as I do? Is your because if you have very different, if you're saying very different, then it might be because they know I'm a TA and therefore they're giving me the answers also.
Ah, okay. Because in just if I log into my this one home page, I can see some progress and then assignment, something like that. If I go into the progress, I
Wait,
can see
can you check your week
okay.
2 assignment 2 again? Because it.
Ah, yeah,
Hmm?
yeah, I can. Give me a second. Just I'm logging into my.
Oh my god.
Yeah, yeah, so you keep continuing,
Okay,
sir,
okay.
on the
Yeah,
other
yeah.
query.
Fine.
Yeah, just
I'll
I
come
log
back
in
to you
and
in a while. Yeah.
yeah, yeah. By the time I log in and
Yeah.
wait.
So the other two things were phototransistors and photoresistors, which I feel are also well understood. Oh, I clicked. Are there any problems with lecture 9? I feel like lecture 9 just had a lot of theory, and there are possible questions, possible mathematical questions from flow, and a little bit from the formula you have in thermocouples, but I do not think that it's necessary to work out these problems. In lecture 10, we had about acceleration and micro electromechanical systems. Are there any questions about the acceleration about the last lecture? Because the last lecture definitely had the most math, and I want to know if anyone had any issues with the formulations and how the equations were derived. Specifically, I'm meaning. Specifically, we are looking at these. I hope these make sense, and there are not many questions based on this. So essentially, the gist of the first part of the lesson is using we can study this from a frequency point of view, and therefore get a very simple relationship between the amplitude and the output amplitude and the amplitude of the vibration. And similarly, if you make a slight modification, we can get a different we can change the amplitude based on the frequency of oscillation instead. So that's the premise of the in the accelerometers. Now, micro electromechanical systems are very useful, and they are used practically everywhere in present modern mechatronic systems. Like they are used everywhere. The slides have a lot of facts, and essentially many of the sensors which we have spoken about so far can has a can have a micro version which is just as capable, and therefore this allows us to have these sensors integrated and part of a very small circuit, and which can be used in many different places. Like we do not need the bulk of many of the previous sensors for things. Naturally, micro electromechanical systems cannot replace every kind of sensors. For example, the ultrasonic sensor I told earlier, it has to be designed in such a way. Similarly, in addition to ultrasonic sensors, we have lidar sensors, radar sensors, and things of that form. And I do not think micro electromechanical systems can replace those. But pressure sensors and strain sensors can definitely be do have micro electromechanical counterparts. And the slides have plenty of data information where you can read out. This is, yeah. So that kind of concludes the revision on the last 5 lectures. Are there any specific questions? Yes?
Yeah, like this piezoelectric sensor and a piezoresistivity sensor,
Yes.
which we are going to use like acceleration and vibro. Uh, uh, this is the how it can differentiate piezoelectric and piezoresistive.
Uh,
Where piezoelectric is applicable, where piezoresistive is applicable.
if I remember correctly, piezoelectric is strictly used in case of pressures and stuff like that. While,
Okay.
oh, give me a second. Yeah, so the output is different, right? The piezoresistive sensors changes resistance, and that's a more constant output. The resistance will not changing the resistance suddenly will not necessarily change the dynamics of the electrical circuits. Piezoelectric system, on the other hand, gives a output of voltage or charge, if you like it that way instead. So they have different uses. Like in the end, it depends on both piezoelectric and piezoresistive things have different stability and dead bands and resolutions and even response times and time constants, and therefore depending on your application, which of these you prioritize, you have to look at the actual sensor values and check it out. Secondly, piezoresistive elements are mostly in micro electromechanical systems, and therefore if you're building such a small system, you need to, yeah, the specifications you need for piezoelectric resistance will be pretty, yeah, I guess it depends on the sensor, the stability and response time. Like you decide which sensor you want based on based on the stability and accuracy and sensitivity essentially. Presently, I do not know which is better. Piezoresistive is used in a very specific niche place. Piezoelectric is more. I've heard of it more often, but that might just. It depends on the use case. Yes. Yes.
Sir, before I log into my home page.
Yes.
If I come to the progress, in progress tab, I can see my name and date and then assignment scored or everything. But I'm not sure where can I check what all the answer is correct or
Can you go to the
uh,
place where you have the assignments? Like this is where you're attempting the questions, right? Where do you attempt the questions?
in the link directly whenever I was getting through the class completed courses and the
Oh,
assignments
so
directly.
do you have this site, online courses?
Just like yeah. This is the one. Yeah. For example, yeah, in the top of that, if you see the progress, review assignment, mentor, and the progress in the top tab. Yeah, announcement about the course,
Wait.
ask a question. Yeah, progress. If you click on the progress, I think they okay. Yeah, here for example, it's showing the assignment completed first is scored 70. Just for the same thing, it is showing for me as well. Just I wanted to see, for example, okay, what are all the questions got
To see the
wrong, and
questions,
then
you can
I
just go here, right? Click week one and then go to the thing.
but that is not highlighting for me actually. Ah, perfect. Yeah, this is where, yeah, because I got a in a discussion where we are asked a question. Some of one asked a question like for the first question. If you go to the first question on the same week assignment one,
Yeah, they wrote
first question
closed
is
instead of
yeah,
closed. Yeah.
uh, closed loop. Yeah, even I did a closed loop, but the score is zero. It's showing so that
Oh, you
even I
wrote
have mentioned as closed loop
you wrote closed
in
with a
my
D.
correct. Yeah, closed loop. Yeah, it was answer supposed to be a closed loop. Even I mentioned the closed loop. It was a dash actually, not the options were there. Yeah, that one. Yeah, closed. But yeah, for that I have mentioned closed loop, but answer is showing zero for me. I think the
Uh,
same question. One of the like a group member asked in the ask a
oh, he no,
question
he
tab.
had made a spelling mistake. He had written closed instead of closed, and I feel like I will have to ask the my teacher in charge for this. I cannot. I do not have the ability to change other people's marks, unfortunately. So
No,
yeah.
yeah, because someone has to. Okay, I mentioned the closed, so answer is correct. In the like in where ask a question group, even mine as well is yeah. Gagan Mehmi
Yeah, he had.
in the assignment.
So I
Yeah,
remember.
my answer is close correct answer, so it's give me a full marks. So even I mentioned the closed loop completely, but even for me as well, it is showing a zero. So can you please take it
Yeah,
into
I'll
further?
I'll ask about this. Yeah.
Yeah, please. Yeah, even thank you. Even I didn't know that for that one only. Even I got a like
Okay. Yeah.
zero score for that. Yeah, even I mentioned the closed loop. I'm not sure in what basis it has selected
Yeah.
from.
I'll clarify this. I'll clarify this by
Yeah,
next class. And Yeah, so I think that's most of everything in the last entire week. In case time permitted, I thought we'll talk a little bit of Laplace transform, but if you because using Laplace transform to solve differential equations is a very common tactic we use, but I'm not certain we have so enough time to go through the entire thing. I only talked about this because we the there's a small we essentially solve this equations using the Laplace transform. And if there are any questions regarding the solution, I could elaborate, but I do not. We do not have time at the moment to go through the entire. Yeah. Can you give me a second? Yeah. Last week there was a small issue with the audio. Is that issue present now?
Yeah, this time is okay.
Okay, fine. Unfortunately, I do not like these earphones that much. I will have to look for more, but okay, okay. I think I figured out what the mistake was. Okay. So if there's any specific questions, I can answer. This will be. Oh, additionally, where are? This is not. You had asked for the video recording. I have it. How do I get the? Give me a second. I am getting the link of the video. So that link will take you to the last week's recording. I'll be making a playlist of this every week. So if you want this week's recording, in a short while you'll be able to see this in my channel. To see your score in the assignment, as Raghu pointed out right now, the easiest way is to check out your progress. Like, if once you open the Swime portal, online course NPTEL site, you can click progress, and when you open progress, you will. Oh, this is not progress. If you open progress, it will tell you how much what marks you get, and so on. And likewise, you can also specifically click the assignment tab and see how much marks you've gotten there also.
In some of the course, like in previous course, I was they are giving this link UDIP link here itself.
Which link?
That this our this link, no, what you mentioned here.
Yes.
Yeah, in last session I was seeing that some courses they given here only, they attached here bottom side.
Inside the Swime portal.
Yeah, Swim portal only it can be attachable, because after the session, after the 1 week they are attaching here. In last sem, I attended some course. After this weekly session, they are attaching here. It
Give
is
me a second, because if I remember correctly, I did.
it is
They
possible.
made an Excel sheet and attached the link there.
Yeah,
Mm.
I did do that. I guess the teacher in charge didn't look at my thing yet. I do not know why, but I will. I have to talk to them about this. Yes. Yeah.
Yeah, it's possible.
No,
So,
they were supposed to have do this earlier. I'm not sure why they took time here. Yeah. Preeti Jain, you can attempt the assignments as many times as you want until the deadline. The I am not certain about which score will be considered. I assumed it's the best score. Okay, yeah. The deadline date is given in the deadline date will be given inside the. I don't want to click this link because in case the answers are given, but yeah,
Deadline date will be there in the mail, whatever we will get
yeah,
for the assignment. Yeah.
yeah, it was available in the link also, where we are week one,
yeah.
quiz week one. If you click
Yeah,
the
yeah,
top
yeah.
side, it will come like the deadline also.
Like for example,
And
if I click week two, which should have been completed for you,
yeah,
it
yeah,
will
it
tell
will,
you that the due date will be given on the top left, top
yes,
right, top right.
and some of the member is asked which is the highest score. That means it's just for clarification to them. Like up to the time 23:59. No, you can attempt a number of time you can attempt, but up to time that will not be take as a it will not give that accepted answer to that. Exactly 24th hours that system will convert which are the right answers, and it will show, and the mark immediately it will come. This is what my experience on this year.
Sir, you mean you can do the multiple attempt
Yes, of
in
course.
within 24 hours? Within 24 hours.
Before 23:59, you can, even then you can partially you can attempt, you can't you can submit also, but that will not be taken as a consider as a your final answer. Only
Accepted.
that 24th hour, 23:59, 24th hour, which are the you are submitted, it was that only system will be considered.
Oh, okay. Thank you, sir. Thank you.
Yeah.
No, whatever things you attempt, if provided you submit it, it will be considered. I think, if I understood that correctly.
Yeah.
Yeah, you can attempt it as many times as you want, and you must submit it. It's important that you submit it. You can't just attempt it and then leave the answers as it is. It won't be saved. You have to submit it. Provide and then once you submit it, you'll consider that as another attempt. Only the last submission score will be considered.
No, after the dead time, that time, if you submit, that will not be able to consider.
Yeah, exactly. If you submit after the deadline, won't be considered.
Yes.
I do not know when which score will be considered, but technically speaking, it should be the last score which is considered, because it shouldn't be right to select the higher score, because technically you'll be able to, if the questions are all MCQs like in the first class, yeah, for the in the first week all the questions were MCQs. Okay, except the first one. So if the highest score is considered, then one student can just waste all his time submitting this 2 to the power 4 to the power 10 times. Like, one student can waste time saying the first answer is tactile switch, first answer is engine temperature, write all the answers, submit it, and then proceed to do all the remaining 10,000 combinations, and then he'll get the highest score. He'll get a high score, which is not right. So I think only the last score should be considered.
Yeah, even then, system doesn't know that up to how many time you are submitted, because system will be considered the end of the minute, which is the answer you are submitted. That only system
Yeah,
will be
that makes sense. Yes, it makes sense to only consider the final score and not the highest. Perfect. Sat is right. Yeah, if you want to leave, you can leave. I'm done with. I've concluded this class.
Okay, sir. Thank you. It
Yeah.
was a nice interaction section.
Yeah.
Yeah, we will be waiting for.
Okay, sir.
Thank you.
Nice to meet you all.
Thank you,
Yeah.
sir.
Thank you. You're
It
welcome.
was nice
You're
session.
welcome.
Yeah. Thank you.
You're welcome, sir.
Thank you, sir.
Yeah. Welcome, y'all. I don't use LinkedIn. I'm sorry. I'm sorry. I don't use LinkedIn. I will be here for a short while, and you can still ask questions. I'm strictly supposed. I'm legally obliged to be here till 7. Yes, so I have uploaded the notes in the Google Drive, and they are supposed to have shared the link as well. But for some reason that's not happened. I will clarify them. I'll clarify the teacher tomorrow. So not you should be able to access both the YouTube links and my notes in the SWIME portal. Yeah. Pleasure to help you all. Bye. I'm sorry, I do not have this information. To be fair, this is the first NPTEL course I'm also taking, so I'll get back to you in the next class. Yeah. Yeah. The only thing I know is that the final exam will be in person, but that's it. I know. That's all I know. And I will clarify with the teachers. Yeah. And it's 7, so I am stopping the recording.